Hi, and welcome back to EdMasters YouTube channel. I'm Avni, and I'm working as a science chemistry subject matter expert with EdMasters. If you don't know about EdMasters, please click the link given in the description box. Even you can see the link on your screens right now. I hope you have watched my other videos, have liked, understood them, and have already subscribed to this YouTube channel. So today I have taken up an organic chemistry topic, and that is some basic principles and techniques. This topic I have picked up from CBSE curriculum for class 11. And why I have picked up this topic? Because generally students fear organic chemistry. But frankly speaking, if you know the concepts, you will fall in love with this subject. So let's not waste more time and let's get started. So I'm going to share a short story with you about how urea was formed and who was responsible for it. So actually, urea was developed by a German scientist named F. Wöhler in 1828. And what he was doing was he was doing some kind of experiment in a laboratory. He was just playing around with that compound, and that compound was ammonium ammonium cyanate, and the molecular formula is NH4CNO. So he was playing around with this compound, and he actually accidentally intensely heated this inorganic compound, which led to the formation of a completely new compound, and that was urea. So when he did some experiments, so he discovered the molecular formula for it. So it is like NH2 C double bond O, NH2, and urea, it is used in fertilizers, and it has many more other applications. So this actually was organic compound. And this organic compound was a surprise for many scientists and even for F. Wöhler, because scientists at that time used to think that organic compounds are produced only under the influence of some mysterious force which is existing in living organisms, and this vital force cannot be produced in laboratories as they are living organisms, like for example DNA, proteins. So they thought that this mysterious force we cannot produce in laboratory. So but when this organic compound was discovered and it was made in laboratory, this led to the formation of many other organic compounds, and it actually opened the gate, and it was the beginning of new era for organic chemistry. So yeah, urea was our first organic compound to be discovered in laboratory. Yo! Okay, so next we are going to discuss is organic compounds. That is, we are going to study much more in detail about the different organic compounds, its representation, and how we write it. But what actually are organic compounds? Organic compounds are those which have carbon in them. So that is that organic chemistry generally revolves around this very important element, that is carbon. So generally you will notice that organic chemistry revolves around hydrocarbons and its derivatives. So what are hydrocarbons? As you can guess from this name, hydro means H and carbon means carbon means C, and its derivatives can be like NH2, oxygen, and sulfur, and much more. So the organic chemistry generally revolves around carbon, and carbon is the most important element in organic compounds. And why is that so? why carbon is so important, So I'm going to discuss one important point, and I'm not going to go into more details about this topic as this topic is quite vast. So I'm going to just discuss a very important part, and that is because it forms stable bond bonds with many elements, including itself. And this property is called catenation. And why is that so? So for this, we have to talk about group number, atomic number, number of valence electrons, its electronic configuration. So let's get started. So carbon group number is, what's carbon's group number? Carbon group number is 14, and atomic number is parenthesis 6. Okay, so carbon's group number is 14, atomic number is 6, and if we write its electronic configuration, it is 2 and 4. So in order to complete its octet, how many electrons it needs? It needs more of 4 electrons, then it will equals to 8 electrons. Hence, carbon is tetravalent. So tetra means 4. Hence, it can form 4 bonds. Carbon can form 4 bonds. Hence, it can form 4 stable bonds to complete its octet. And this can be with H, it can be with O, it can be with NH2. So these are the different derivatives of carbon. And just for the knowledge, CH bond is the stablest bond, then CC bond. It's because of the less difference of electronegativities between them. Hence, CH bond is the stablest bond, then comes CC bond. Okay, so now we know that organic chemistry revolves around carbon. And why carbon? Because it has the property of catenation, and it can easily form 4 bonds to complete its octet. So now we are going to discuss is the structural representation of organic compounds. That is how we write the organic structure. So basically there are 4 ways to write down. One is Lewis dot structure. Second is dash structure. Third is condensed structure. And fourth is bond line structure. So we are going to discuss one by one. And first is Lewis dot structure. So you can guess from its name that it was given by the scientist Lewis, and we also have Lewis acids. So this was given by the scientist Lewis. And what does this dot represent? This dot represents number of valence electrons. For example, let's get started with the simplest example, that is carbon. Carbon has, as we discussed, has 4 valence electrons. So if I write 1, 2, 3, 4. Okay, so another question can come into your mind that why we can't write like this, 1, 2, 3, 4, or 1, 2, 3, 4. Why I cannot write like this? Well, This is the most stable representation of writing the carbon element. In 2D, it looks like this, but as it has tetrahedral structure, so in 3D, it looks quite different. But still, this is theoretically, this is the stablest form. And why we cannot write like this? Because we know that electrons are negatively charged. And when two negatively charged come together, what they do? They repel. So that's why this is the most stable representation, and this is how we are going to write it. Let's take another example, HCl. So Cl has 7 valence electrons and H has 1 electron. So let me draw these dots which represents valence electrons. 1, 2, 3, 4, 5, 6, 7. When H and Cl come together, they form a bond, and this bond is represented by a single bond, that is dash, and this dash means bond. Hence, this gives us the second way of writing it, that is dash structure. So single bond represents, one dash represents single bond. Double bond is represented by double dash, and triple dash means triple bond. Okay, so this is how we represent the chemical compounds in the dash structure. Also, you have a choice whether to represent lone pairs or not, whether to draw lone pairs or not. I can draw it as well, 1, 2, 3, 4, 5, 6, or I have a choice not to draw them. For example, like in CO2, I can write the structure like this, or I can write the structure like CO, 1, 2, 3, 4. Whichever way you find is better, you please use that. Also, instead of dots, we can represent by crosses. Like, for example, ethane. Its chemical formula is CH3CH2. So 1, 2, 3. Here, see, if we going to represent by a cross, we might get confused whether it's of C or whether it's of H. So, better way to write is 1, 2, 3, a dot for H, which will tell us, okay, so these are the electrons and it is represented by different atoms. Like this. So carbon is representing valence electrons of, cross is representing the valence electrons of carbon, and dot is representing valence electrons of hydrogen. So if we write in a dash form, we can write like this. Easy, right? Okay, so let's go to the next part. That is condensed structure. In this, we write the chemical formula in a condensed form. Like instead of writing CH and showing number of dashes, so many dashes, which is such a tedious job, we write like CH3, CH2. Or what else we can do is, for example, we have, this doesn't represent electrons, it's just a bullet. So we have this long molecule CH3, CH2, 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 CH3. Okay, so what we can do is we have to write in a condensed form. So CH3, CH2, 5, and CH3. That is 1, 2, 3, 4, 5, 6. So 1 CH3, 1 CH, number of CH2 are 5, and then is CH3. So if we have to write like CH3OH, is this a condensed structure or a dash structure? This is a condensed structure. The dash structure will be like this. So this is a condensed form to write it, and it is easier to write and faster to write. Okay, so next is bond line structure, and this bond line structure is mostly followed by the chemists and scientists. In this, what we do is carbon and hydrogen are not shown. Are not, oops, what happened? Some drawing happened. Are not shown, and lives, not lives, lines representing carbon bonds are drawn in zigzag fashion. Well, chemistry also follows a fashion. Well, CH3, CH2, CH3. If we have to write this formula in a bond line structure, we are going to write like this. So basically, if you can't straight away write to this, what you can do is you can write like this: CH3, CH2, first step, CH3. Okay, now omit carbon. Now omit hydrogen. Now this is the correct representation of this molecule. Okay, so let's take another example like CH3, CH2, CH, CH3, CH2, 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 CH3. Oof, long molecule. Okay, so how many carbons are there? Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 C's. And how are we going to write in the zigzag fashion? Like 1, as this is terminal. If you get confused, then first write by CH3, CH2, CH, CH2, 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 CH3. That's how I write it, guys. And oh my God, what happened? Okay, let me write neatly. Okay. So this we have to represent. Otherwise, if we don't show it or we write like this, so if we don't show it or we write like this, then this means that there isn't any bond here. So we do have to represent by CH3. Also, we can avoid writing CH3. If we write like this automatically means there is a terminal CH3. So CH3, CH3, and CH3. Okay, so actually, few points to discuss is terminals denote methyl group unless it is shown by functional group. So, for example, if CH3, CH2, CH2, CH3, CH, Br. Okay. So if we have to write in a bond line structure, see, if you are not going to write any functional group here, like Br, then the marks will be cut. You have to represent it PR here. You can't just leave like this. Okay, so I have to leave like this. No, only you can leave if there is CH3. You don't have to represent C, you don't have to represent H. There's just that, keep in mind. Also, cyclic structures. If we have to write cyclopropane, let me write in a dash structure. So how it's gonna be? If I omit C, I omit H like this. Cyclobutane like this. Cyclopentane like this. Benzene ring like this. Okay, I'm not drawing. I'm not doing some kind of a drawing. So this is how we represent different chemical organic compounds. So now is a summary time. So what we studied how urea was formed, formation of urea by F. Boiler in 1828, formation of urea, it was accidental formation. Then definition of organic compounds, why organic compounds, we studied why carbon is important. Then we studied how to write organic compound, that is structural representation, and there were 4 ways to write down. I hope you understood few basic concepts of organic chemistry that we discussed. Please like, share, subscribe to this channel for more updates and for more videos. Also, let me know in the comment section whether you understood this topic and your concepts got cleared. And do let me know if you want me to take up another topic which is related to science or chemistry. So see ya, bye bye, and have a nice day ahead.